Hey everyone, today we are going to be continuing talking about solving one-step equations. And today we are going to do our other two operations. So we're going to be doing multiplication and division. So first we're going to talk about the properties of equality that go with these two. So I've got the division property of equality and the multiplication property of equality. Now the division property of equality says that for any numbers a, b, and c, where c is not 0. This one is important for this case because we cannot divide by 0. You can't share something in 0 equal parts. If you ask Siri, she gives you a really funny answer. And when we do this in class, I will have everybody try 5 divided by 0 in the calculator. And you guys are going to tell me what happens and what the calculator tells you. But you cannot divide by 0. So that's why it tells you that C can't be 0. And then it's the same thing that we looked at with addition and subtraction. If I add the same thing to both sides or subtract the same thing to both sides, it remains equal. The same thing happens with division. If I divide A by a number and if I divide B by that exact same number, the two sides remain equal. The multiplication property of equality works the exact same way. If I have those same numbers, A equals B, and I multiply by another number, as long as it's the same, the equation remains true. So what does this mean? It means when I multiply or divide each side of an equation by the same number, those two sides remain equal. And then just a reminder that inverse operations are the operations that undo each other. And today we're talking about multiplication and division because those two things undo each other. You'll notice that my little scroll is still here, so I've still got my steps here. Remember that steps 1 and 2 are required before you may ask for any assistance with solving because they do not require any extra skills. So everyone can draw the line through the equal sign and everyone can circle or highlight the variable. So I've gone through and I've done that for all of my equations already. So now we're going to look at, I've got two examples here of the different kinds of equations that you're going to be seeing. Number 1, it says 9y equals 67.5. Well, 9y actually means 9 times y. So when I'm identifying the operation that I'm doing in this equation, I'm actually doing multiplication. And when I go to solve, I'm going to use division. But when I do division in these equations, I'm not going to show it with the traditional division symbol. We're actually going to show it by drawing a line underneath both. This is going to be kind of like a fraction bar. And we're going to use that to represent division. Okay, so we're going to be looking at division and multiplication a little bit differently. We've been working on this idea of a number next to a letter means multiplication. And now we're going to add in that we're using the fraction bar to represent division. So I'm actually going to divide by 9 on both sides. And here, 67.5 divided by 9 is equal to 7.5. I used a calculator to get this answer, and you are also allowed to use a calculator. So now I'm going to check and make sure. So I'm going to do 9 times 7.5 is equal to 67.5. And then I'm going to go ahead and check that in the calculator. 9 times 7.5 is indeed 67.5. And just a reminder that this checkbox should always be true. So if you are getting something in the checkbox that is false, then you need to go back into your original work and check that you did not make a mistake in your calculations above. In this second question, number 2, this x over 4 means the same thing as x divided by 4. But when we're solving equations, we're not going to see it with that traditional division symbol anymore. We're going to see it with a fraction bar. So to undo x divided by 4, I'm actually going to multiply by 4 on both sides. So I'm going to draw parentheses around both sides of my equation, and I want to multiply by the number that's in the denominator. So I actually want to multiply by this number down here. So I'm going to multiply by 4 on both sides. And on the left-hand side, with the variable on it, you can see that I made the 4 look like it was on top. Because when you multiply by that number, you are actually multiplying by 4 over 1. And if I cross cancel like I'm supposed to, these 4's both go away. When those 4's both go away, all I'm left with is the x that's on top. And then 20 times 4 is 80. And then I'm going to check my solution. So I'm going to put 80 in for x. So 80 over 4 is equal to 20. And then when I actually do this division, 80 divided by 4 is 20. So 20 equals 20, and my answer checks out. For the next one, this 2/3 x equals 8. The fraction is going to represent division. And then the 2/3 x actually means 2/3 times x. So what we can do in this one is we can actually look at it as something that includes both me having to undo multiplication and division. And when I have to undo both, I want to undo the division first. So I'm actually going to get rid of the fraction first, because that's going to make things a little bit simpler. So I'm going to multiply both sides here. And I'm going to put parentheses around both sides. And I'm actually going to multiply both sides by 3. Now when I multiply both sides by 3, this 3 becomes a 3 over 1. And it cancels out when I do my cross canceling. And then I'm actually left with this 2x. So I've got a 2 left over, and then I've got the x left over. That's going to be the multiplication that we're going to undo. So I've got 2x left over, and then 8 times 3 is 24. So for the first part of this, I did what I did in the last problem. Okay. Now for the next part of this, I'm going to undo the multiplication like I did in number 1. So I'm actually going to divide by 2 on both sides. So x equals 12. So that worked out pretty nicely. And now I'm going to check. So I'm going to say, is 2/3 times 12 equal to 8? Well, when we did multiplying fractions by whole numbers, we changed that fraction we changed that whole number into a fraction over 1. So I'm actually going to do 2/3 times 12 over 1 is equal to 8. And when I cross cancel, I get a 4 on top. Well, 2 times 4 is 8, so that works out. For number 5, I'm undoing multiplication. To undo multiplication, I'm going to divide. So I'm going to divide by 8 on both sides. So x equals 9. So I'm going to do 8 times 9 equals 72. And 72 is indeed equal to 72. For number 6, I'm going to undo my multiplication on the right-hand side here by dividing by 3. And this one, when I check in the calculator and I do 5 divided by 3, I get 1.6666666 on and on forever until it eventually becomes a 7 at the end. Because this one is a repeating decimal, I'm actually going to leave it as a fraction, because it's a more exact and accurate answer. So I'm actually going to leave this as x equals 5 over 3. You are allowed to leave your answers as fractions if you would like to. I would actually prefer them that way. So now I'm going to check. So 5 is equal to 3 times 5 over 3. And just like in this one over here where I did the 12 over 1, I'm going to do the same thing with the 3. So 5 is equal to 3 over 1 times 5/3. And when I cross cancel, 5 is equal to 5. So that checks out. Number 7 is very similar to the second problem. So number 2. And I'm going to undo this division by multiplying on both sides. So I'm going to put parentheses around both sides. And I am going to multiply by 5 on both sides. So my 5's cancel. And I get 35 is equal to k. And then I'm going to check my work. So is 7 equal to 35 divided by 5? It absolutely is. Okay. So today we are looking at multiplication and division in a little bit different way. So our multiplication, that number times a variable, and then now our division is going to be represented as fractions. So we're going to be using the all the work that we've done with multiplying fractions and cross-canceling and all of those things. There's no homework today. We'll be doing a practice day in class tomorrow.